Well, good morning to you guys and welcome to our exam review. Again, sorry about the circumstances, but we do what we can do and try our best to make it all work. And so our exams this week are going to be over the following chapters 6, 7, 8, and 9. And so I just wanted to go over the problems from the entire packet. It may take some time and make sure that you get your questions answered. Again, if at any time you have any questions about these problems or you want to ask me something, you can send me a quick remind message and I'll try my best to get back with you as soon as I can to answer the problems that you have. And I want you to go ahead and take these problems and study them over the next day or two so that you are prepared for the exam. The exam will have 7 open-ended questions on it and 45 multiple choice questions on it, again in 2 parts. And calculators are most certainly allowed. I'm going to be using mine quite a bit on this exam review. We're going to start with number 1 in chapter 6, and we are talking about exponential functions in this chapter. And so we have an exponential function here called g of x equals 2 times 3 to the x power. And the first thing that I want to do is go ahead and put that into y equals. Y equals is where most of your stuff is going to be happening, and so we're going to do 2 times 3 to the x power. And what I can do is I can go to second table, which is second graph, and I can look at these values that are here. Let me scroll up. I'm going to go up to -2, -1, 0, 1, and 2, and then just write the numbers down in the table, which are 0.2222. Move this off to the side. 0.222, which is really 0.2 repeating, 0.6 repeating, 0, 2, 1, 6, and 2, 18. I know that we have done a few of these in class, between first, fourth, and sixth hour. A lot of you chose different numbers to do up on the screen, so we'll just go ahead and do them all to make sure that everyone is all set. So these are the values that I have off the table, copied down on my paper, and we're going to go ahead and graph those values. 0, 2 is here, 1, 6 is there. 218 is way up off the grid. We'll put it up there at the top of the page. -1, 2/3, and -2, 2/9. And so it looks like that we come right along here and grow at a very fast rate. That's why it's an exponential function. I want you to notice that it comes closer and closer and closer and closer to the x-axis, but never touches it. Okay, and that would be something called an asymptote, and we're going to be able to find the equation of that as well. The domain of every exponential function is -infinity to +infinity because it goes left forever and right forever. The range is the up and down values, right? It goes up forever, so it goes up to infinity, but the lowest value is here, in this case, at the axis. It gets closer and closer and closer to the axis, but never touches it, so it gets closer and closer and closer to 0. But never gets to it. That's why there's a round bracket here. The y-intercept is always found at 0, in this case 0, 2. You can look on the table and see 0, 2 there. My horizontal asymptote is always y equals, okay, because it's a horizontal line that goes through the y-axis. And since it gets closer and closer and closer to 0, this one is going to be y equals 0. And this one is increasing because it increases to the right forever. We're going to move down here to 2 and 3, and I'm going to ask you to tell me whether or not the function is linear or exponential. And we're going to look at the patterns of the y values. Look at these y values here. We check out the patterns. Notice this is down 3, down 3, down 3, down 3. And so the pattern is -3. And what that means is that when you're adding or subtracting something over and over and over again, that means it's a linear function. When you're multiplying or dividing something over and over and over again, that means it's an exponential function. And just to take things a little bit further, we could also even write down the equation of these. Okay, so in this case for the linear function, I know a lot of you may not have done this, but go ahead and write it down anyway. The linear function is going to be y equals mx plus b, right? And the m value is the slope, or we'll write this down as y equals mx plus b, or in this case, how the y values change, or the changes in the y's over the changes in the x. And so if you look at the y values are going down by 3, that's going to be the slope. So it's going to be y equals -3x. Now the b value is the y-intercept, which you know always occurs at 0. And in this case, you can see that that value is 8. So the equation would be y equals -3x plus 8. Let's do the same thing for part b. If you notice my y values What is the pattern? Multiply by 3 every single time. And you can use your calculator for this to determine what the pattern is. And since we're either multiplying or dividing over and over and over again, we know that the function is an exponential function. And let's go ahead and write the equation. If you remember, exponentials have the form y equals a times b to the x. Okay, where a is what is called the starting value. The starting value is at 0, and so that 9 is going to go right here. So the equation is going to be 9 times, and then b is how the function is changing, in this case, multiplying over and over and over again by 3. Okay? Let's turn the page. Do we have anything on the back of this? We do. And so we're going to look at some exponential growth and decay problems from Chapter 6 as well. Again, we're looking at, I want to get the equations here at the top of the screen. For growth, what we have is y equals a times 1 plus r, and that's raised to the t power. And then for decay, we have y equals a times 1 minus r, and that's raised to the t power. I am going to give you a formula sheet on the day of the exam with all kinds of formulas on it. Growth and decay, exponentials, linears, quadratic and standard form, quadratic and vertex form, what is the quadratic formula, what is the equation for the discriminant, and so forth. And so you don't have to memorize any of that stuff. The a is the starting value. So for part A, the exponential growth is the starting value of the population of the town, in this case 3,500 people. The R value is the rate, and the rate is the percent at which it's growing, in this case 4%. We generally take the percentages and change them to a decimal, and so we have to change that to 0.04 when I plug it into the equation. Now the growth or decay rate is the B value, okay, and in this case is going to be 1 plus 0.04. And so the growth or decay rate, in this case the growth rate, is going to be 1.04. And the equation is going to be y equals a is the starting value, 3,500. B is the growth rate, 1.04. And we're going to take that to the t power. Now t in these cases is time. And so what they want you to do is predict the population after 2 years. And so in my calculator, the calculator is going to do all the calculations for you, is going to be 3,500 times 1.04, and I'm going to raise that to the t power. So we're going to go ahead and put that in here. This is going to be, second quit, go back to the home screen, 3,500 times 1.04, and we're going to raise that to the 2 power because it says how long after 2 years. Now, generally, we don't use decimals for populations or animals or, whatever like that. We want to use a whole number. So I'm going to round to the nearest 3,786 people. And so that's going to be the population, the new population of the town after 2 years. So that's the process that we would follow for that. Same for the exponential decay, except the value is going down, and we're going to use 1 minus. The A value is the starting value of the boat, so we're going to put $25,000 here. R, in this case, is going to be 8%, and we're going to put that as a decimal as 0.08. Make sure that you don't put that as 0.8, because that would be a decrease of 80%, and you'll get a much different answer than this. The B value is the growth or decay rate, in this case, 1 minus 0.08. which I could write as 0.92 if I want to make it easier. And the equation is going to be y equals, the A value is 25,000, times B is the decay rate, in this case 0.92, and that's going to be raised to the t power. Now the question asks us, how much is the boat worth after 5 years? So in the calculator, we're going to put 25,000 times 0.92, and we're going to raise that to the 5th power. So we'll get our calculator out, 25,000 times 0.92. We're going to raise that to the 5th power. And it looks like the value of the boat after 5 years is $16,477. Let's round to the nearest cent. And it looks like 4 cents, so 0.04. Put a $sign there, and we are all set. Also in the concept of exponentials is something called a geometric sequence. Okay, and so geometric is only talking about a pattern or a sequence of numbers that multiplies or divides repeatedly. Remember, adding or subtracting is called an arithmetic sequence. Arithmetic for adding and subtracting, geometric for multiplying and dividing. And if you notice, this is times 3 times 3 times 3. And so the answer for part A is going to be yes. And it says, if so, identify the common ratio. The common ratio is R. And will tell us what are we multiplying or dividing by over and over and over again. And so the answer for that is going to be 3. Notice for part B, what are we doing here? Minus 12, minus 12, minus 12. It looks like we're subtracting 12 over and over again. The answer for that is going to be no, because we can only multiply or divide over and over and over. And it looks to me here like this is half, half, half. Maybe dividing by 2 over and over again. And so this is going to be yes, and the R value is going to be equal to 1/2. So that wraps up chapter 6. And go ahead and turn your paper over. We'll go to chapter 7. I know there's quite a few here that we did not get to. We're going to write the polynomial in standard form. We're talking about polynomials in chapter 7. More of adding and subtracting polynomials and multiplying polynomials using FOIL and the distributive property and stuff like that. In this case, we want to put it in standard form. Standard form means I'm going to start with the highest exponent first, and so the 9x squared is going to go first. And then the 12x is going to be second because it's really 12x to the first. And then the minus 7 is going to come down here. It says then name the polynomial based on its degree. And so we're talking about the degree of 2. If you remember, a degree of 1 is linear. A degree of 2 is quadratic. A degree of 3 is cubic. And a degree of 4 is quartic and so forth. And there's more, but we'll stop there. But in this case, we have a quadratic polynomial. There are 3 terms that are either added or subtracted. And so this is going to be a quadratic, trinomial. And we're done with that problem. Part B, the first term we need to put is the third power, and then the 4x squared comes second. A polynomial that has the highest exponent of 3 is called a cubic, C-U-B-I-C. There are 2 terms, and so this is going to be a cubic binomial. And we are done. Just remember binomial, bicycle, whatever has 2. 15x, think of this as 15x to the first power. And anything to the first power is called linear. And one term is going to be a monomial. So this is a linear monomial. Notice it's already in standard form, so I don't have to do anything to switch it around and so forth. Polynomials can be added or subtracted. Okay, and so we're just simply going to combine like terms. Like terms would be the terms that have the same exponents. And so what I have here is 9x to the third, and 2x to the third is going to be 11x to the third. Notice here I have a squared term, but it's all by itself. I don't have a squared term over here, so that one just has to come down alone by itself. This 5x can't go with anything, so I'm going to bring that one down separate and just leave it there. This is a constant, minus 12. This is a constant, plus 8. And so I put them together, and I have a minus 4, and we are all done. For part B, we are subtracting the polynomial. Just remember that the minus has to be distributed or applied to every term in the second polynomial. And so what I have here is 6x squared minus 5x squared is just 1x squared. I'm going to leave the 1 off. A negative 8x minus, remember it's minus 4x, is going to be a minus 12x. And minus 3 minus minus 2. So there's a minus here that goes with that minus, and a minus minus is really a plus. And so minus 3 plus 2 is a minus 1. And so there's my polynomial. That's adding and subtracting. Multiplying, sort of the same process, except we're going to distribute in part A. I'm going to take the 5x squared and multiply it by each of those. So 5x squared times 2x cubed, well, 5 times 2 is 10. And remember, when multiplying exponents, we add. Okay, so if I multiply an expression with exponents, I'm going to add the 2 plus 3, so it's going to be 10x to the 5th. Next, we have 5x squared times negative 8x. Well, 5 times negative 8 is negative 40. And x squared times x is x to the 3rd. And 5x squared times 7 is going to be a 35x squared, and we are done with that problem. Essentially, your job in these questions is to eliminate the parentheses, and you eliminate the parentheses by multiplying using the distributive property. The next three questions, we're going to use something called FOIL, which you've done 100,000 times, first, outer, inner, last. And I'm going to multiply those terms. So first times first is 5c times 8c is going to be 40c squared. 5c times outer is going to be 5c times negative 3 is negative 15c. Inside problems is going to be 2 times 8. 2 times 8 is 16c. And last times last, 2 times negative 3 is going to be negative 6. Now, for full credit, we're going to take the two middle terms and combine them like we did earlier. And so my final answer is going to be 40c squared plus 1c minus 6. And so that's going to be my final answer here. Notice I took the 1 and I left it off because you can. I'm going to take problem C, and when I square this, I need to rewrite it twice. I want you to notice something that some people here might put 16n squared plus 9. Someone's going to tell me that because 4n squared is going to be 16n squared, and 3 squared is 9. You're done, right? I guarantee you that this will be one of the multiple choice questions, one of the multiple choice answers if you were given this on the test. This is not right. Okay, the two terms are correct, but we're missing something. Well, first times first is the 16n squared. Notice outer is 4n times 3, which is 12n. And inner is also 4n times 3, which is 12n. And then last times last is 3 times 3, which is plus 9. And now what I can do is take the two middle terms and add them together. Final answer, 16n squared plus 24n plus 9. Okay? And again, if you're watching this video, feel free to pause. If I'm going too fast or you need to get caught up or write something down, pause the video for a second, get caught up, and then resume. You look at problem D here, we have really the same things except one is a plus and one is a minus. 4p times 4p is 16p squared. Notice in a problem like this that outer is negative 20p, inner is positive 20p, and those will cancel. And so I'm just worried about first and last. In this case, 5 times 5, oops, I wrote a 1, is going to be minus 25. So the final answer is 16p squared minus 25. Anything on the back of the Chapter 7 page? There is, so let's keep right on moving. Here we're going backwards. We're taking those things that we just did and we are factoring them, okay? So it's really everything that we did multiplying, just going in reverse order. The GCF of the polynomial is the highest thing that goes into each term. In this case, if you notice, we have a 49 and a 14. That would be a 7. And then we use the lowest exponent on each variable. And so my lowest exponent is going to be m to the 5th. The reason being is that 7m to the 5th can go into every term, and I'm just going to divide those out. So in this case, I have 49 divided by 7 is 7. M to the 8th divided by m to the 5th. When you divide, you subtract the exponents. So this is going to be 7m to the 3rd on the inside. And 14 divided by 7 is 2. And your m to the 5th divided by m to the 5th cancels. And so this is my final answer right here. We'll do the same thing with part B. I'm looking for the GCF. Look at the numbers 18, 24, and 36. Let's see, 2 goes into each one, 3 does not go in, 3 goes into each one also, and 6 goes into each one. Anything higher, 8, 9, I think 6 is going to be as high as we can go for that. And then I use the lowest exponent, in this case, 6x to the 3rd. And so what I'm going to do is take the 6x to the 3rd and divide it out. 18 divided by 6 is 3. 18 to the 6th divided by 18 to the 6x to the 3rd is going to be 3x to the 3rd. You subtract exponents. 24x to the 3rd divided by 6x to the 3rd. The x to the 3rds cancel. And 24 divided by 6 is 4. And 36 divided by 6 is going to be 6. And we have an x squared. And that is all. Now, for these problems in number 5, we're talking about reverse FOIL. So give me two sets of parentheses here. I want to know what two binomials were multiplied in order to get this trinomial. Well, I have an x squared in the front, so we know that's x times x. And I'm looking for the factors of 48 that add up to 16. Well, I know that 12 times 4 is 48, and 12 plus 4 is 16, so those are the numbers that I want there. The 48 is positive, which means the signs are the same, and the plus is in the middle, so it's going to be plus plus, and we are done. Same thing with part B, 2 sets of parentheses. Out in the front is an x squared, so that's going to be x times x. I want factors of 72 that subtract to 21. Well, I think about 8 times 9. That's 72, but that doesn't give me 21. 36 times 2 doesn't give me 21. What about 18 times 3? No, 18 times 3 is 54. How about 24 times 3? Let's see. 24 times 3 is 72, and 24 minus 3 is 21, so that's going to work. Is going to be 21 times 3. Kind of a tough one. But notice the 72 is minus, so that means the signs are different, and the minus in the middle goes to the larger number, and so it's x minus 24 and x plus 3. With problems like C and D, what I want you to do is put 2 sets of parentheses down, because eventually we're going to reduce them after our repeated factor. So out in the front we have a 2, so it's going to be 2x and 2x. You're going to repeat the factor. You're going to take the a times c, which is 2 times 15, and make that 30, and then I can ask myself the same question. What are the factors of 30 that add up to 11? And that's going to be 6 times 5. Again, like problem A, my c value is positive, and that means the signs are the same. My middle term is plus, so they're going to be positive, positive. And then for the second step, I reduce. 2 goes into both of these, so that's going to be x plus 3. What goes into both of these? Nothing really does besides 1, so we just leave that one the same, and that one's factored, and we're all set. Do the same thing for problem D. Out in the front, I have a 3, so we're going to do a repeated factor of 3x and 3x. First times last is 3 times 8, which is 24. And so I want factors of 24 that subtract, there's a minus there, to 10. I think of 6 times 4 gives you 24, but that's not going to work because it's 6 minus 4 is 2, and we want to subtract to 10. What I think of is 12 times 2. 12 times 2 is 24, and 12 minus 2 is 10, so that works. My 8 is a minus, so that means my signs are different, and the positive goes to the larger, so we'll put a plus here and a minus there. And now we reduce, divide these by 3, gives me x plus 4. Nothing goes into 3 and 2, so we leave that one alone. Okay? And for our last 2 questions, E and F, these are something called dots, a difference of 2 squares. And a difference of 2 squares is factored like this. Here I have, if you want to think of it, this is really 36 is 6 squared, and that's why, because it's a difference, that's a minus. Okay, and these 2 values are squares, and so we're all set. X squared is going to be x times x. 36 is going to be 6 times 6. Notice there's no middle term here in the middle. It's really a 0, and so one's plus and one's minus, because when you add those together, they cancel. Same thing for this one. Difference of 2 squares. Out in the front is a 16x squared, so it's going to be 4x times 4x. Remember, these have to be the same. 5 times 5 is 25. One is plus and one is minus. Okay? Let's turn it over. We're going to move to Chapter 8. We are talking about quadratics in this chapter. Quadratics and parabolas. Again, for this function here, we're going to type it into y equals so we can get the table values. I'm going to go to my calculator and get y equals here. This is going to be 4 minus x squared. Clear that out. Let's go to the table, and it looks like 0, 3, 4, 3, 0 for our numbers. So in our table is going to be 0, 3, 4, 3, 0. Okay, negative 2, 0 is here. Negative 1, 3 is here. 0, 4, 1, 3, and 0, 2. Sorry, 2, 0. Sketch a nice little parabola. It's going to look something like this. Okay? The vertex is the point at the very top or the very bottom, so this point at the very top is going to be 0, 4. The axis of symmetry is always x equals. There's an imaginary dotted line that goes down through the middle like this, and the equation of that line is the first value of the vertex, in this case x equals 0. This parabola has a maximum because it's at the very top of the parabola. The domain is always the same. It goes left forever and right forever. Negative infinity, positive infinity. Notice the range is the up and down value, so this goes down forever for sure. So we're going to start this with a negative infinity. And as I work my way up, the very top value is 4. The 4 is included, and so I need you to put a square bracket right there. The increasing interval is where it's increasing. And notice this is going up, 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 up to here. And so that value is 0. And so it's starting at negative infinity and going to 0. And then starting at 0, it goes down, down, down to the right. And so that's going to be 0 to infinity. Okay? The a value that's out in the front can change the look of the parabola. And so in this case of number 2, the a value out in the front is 4. What I think of is when you take a higher number than 1, it stretches the parabola up tall, and tall parabolas are narrow. In this case, my a value is positive, and so we know that it's going to open up. Again, my b value is going to be negative 1/2. Any number that's less than 1 is going to shrink the parabola down short, and anything that is shrunk down is going to be wide, and this one is going to open down because the a value is negative. Order the quadratics from widest, that would be the smallest number, to narrowest, which would be the highest number. I suggest you organize these as A, B, C, D, and then we'll put them in order. Widest is the smallest number. In front of B, there's an imaginary 1 there, so that one's going to go first. Then we have a 2, 4, 5. So C, A, D. That's the order from widest to narrowest. Again, let's label these A, B, C, D. Which one is the smallest number? It looks like 0.1 is the smallest here, so that one's going to go first, D. The next smallest is going to be 0.25, and so that's going to be A. Out in the front here is a 1, and so that's going to be B. And then this is the biggest number here. Don't worry about the negative. I don't care about those negatives, right? Those negatives are just going to flip it upside down. And what we're talking about here is widening and narrowing the graph. Okay? On one of your formulas, on the formula sheet, I'm going to give you something called vertex form, which looks like this. Your vertex is found at HK, which we talked about is Hello Kitty. And so in this case, the h value is the number that's inside the parentheses. Notice the h is here in the parentheses, and it's always the opposite value. In this case, we have an x plus 4, and so the h value is a negative 4, and the k value is a negative 5. Okay? Identify the vertex and the axis of symmetry. Well, the axis of symmetry is always x equals because it's a line that goes up and down, and it's the first value of the vertex, in this case, negative 4. And then identify if it's a max or a min. Well, look at the a value out in the front. The a value out in the front is 3, and that tells you one thing, that the parabola opens upwards. And when a parabola opens upwards, it has a point at the very bottom, and so the point at the very bottom is called a min. Okay, move on to part B, same thing. The vertex is going to be found at HK. The h value is here. It's a minus on the inside, so we change it to a positive. And the k value is 3. The axis of symmetry is always x equals the first value of the vertex, because your vertex is on the axis of symmetry. And notice my a value out in the front is negative, which means my parabola opens down, something like this. And so a point at the very top is going to be called a maximum. Okay, let's go ahead and turn the page. Some stuff to do here on the back. Number 4. What does it say here? For the given functions, identify a, h, and k and graph the parabola. Well, the a value is right out, it's invisible. There's going to be a 1 there. And my vertex is going to be opposite of h, so that's going to be negative 2, and the k value is negative 3. So really all that we need to do is graph the vertex and then use the a value to graph the parabola. Left 2, down 3 is here. My a value says it's upwards, and so I'm going to graph an upwards parabola just like that. Okay, same thing here. We have a 1 out in the front, and so that's going to be 1. And my vertex is found at h. Now notice there's nothing being added or subtracted to the x in there. So it's going to be 0, and the k value is going to be negative 6. So I'm going to go down 6, put a point. I'm going to graph a nice parabola that's upwards because my a value, again, is equal to 1. Move on to number 5. Again, here's vertex form. The transformations are provided. Write the equation. Well, if I'm going to go 3 units to the left and 5 units up, what do we do? Think of the vertex. If I'm going to the left, that's a 3. And if I'm going up, that's a 5. So those are really my h and k values. So all I need to do is write y equals x minus 3, because my h value is positive, so I change it to a minus, and the k value is plus 5, and we are done. Again, if I'm going 8 units right, the h value is negative 8 because it's going to the Okay, well, 3 units left. Let's go back here and fix our mistake. 3 units left, we're going to the left, and so that's going to be a negative, which is going to change this to a positive. That's an easy fix. 8 units to the right is going to the right. I need to practice my lefts and rights here, people. 8 units to the right, I'm going to do a plus, and 4 units down is going to be a negative. Sorry about that. So y equals, okay, and then x, this is a positive 8, is going to be minus 8, and that's a quantity squared, and then a minus 4. Okay, oops. All right, couple of things here for part C. It's reflected across the x-axis. That means it's flipped upside down. And it has a vertical stretch. That means it's narrow. By a factor of 4, you're stretching it out. And so all we need here is a negative to flip it upside down. And a vertical stretch, or making it narrow, is multiplying by 4. So the answer is negative 4x squared. Part D, a vertical compression. That means you're smashing it down. That means it's going to be wide by a factor of 1/2. Notice that thing is going to be less than 1. And so I'm going to put a multiplying factor of 1/2 out in the front. And it's going to go to the right. Let's go to the right this time. And so we're going in the positive direction, so we need an x minus 5 on the inside. Okay? Last 2 of this chapter, and move on to chapter 9. Linear, quadratic, or exponential. All right, we got to choose one of these 3 options, and then we have to explain. Well, notice I'm multiplying by 2 on all of these populations. And so when you're multiplying by 2, just like we mentioned before, is going to be an exponential function. And I think multiplying by 2 is a good enough explanation for me. Look at these y values. What are we doing here? It looks like minus 0.3, minus 0.3, minus 0.3 over and over and over again. And when you're subtracting or adding over and over, that's going to be a linear function. Okay? Final chapter. Turn the page over. Let's move on to chapter 9. We are talking about roots and quadratics and the solutions of parabolas. So when it says, what are the solutions of this? We're going to take this thing, we're going to graph it in our calculator, and we're going to see what it looks like. Go back to y equals. The function is x squared minus 9, and I'm going to throw that on the graph and see what it looks like. Well, this doesn't give me very much, so I'm going to hit zoom 6, and that'll take me to standard graphing, and I have a nice parabola that looks like this. Notice this is going to cross the axis in 3 and negative 3, so those are good things to note. I put a point here at 3 and negative 3. And I graph my parabola, which looks something like this. Again, the parabola doesn't have to be perfect, but I just want to know where the solutions are, and they are written as plus or minus 3. Okay? In 2, 3, and 4, we are talking about the discriminant. What is the number of real solutions? 2, 1, or none, which would be 0. Let's write down the formula. The formula for the discriminant is b squared minus 4 times a times c. Okay, and so in this case, I'm going to say the discriminant is b squared, because this is a. I'm going to label this here, a, b, c. The b squared is 6 squared minus 4 times 3 times 7. Okay, let's type that in the calculator so we don't have to do it in our head. Second quit. 6 squared minus 4 times 3 times 7. And hit enter, and that gives me a discriminant of negative 48. And when your discriminant is negative, remember you're taking the square root of a negative, and you cannot do that, and so it's going to be 0 real solutions. You could even put 0 RS if you'd like. Let's do the same thing for number 3. b squared minus 4ac is going to be 10 squared minus 4. The a value is 5, and the c value is 5. Use the calculator to figure this out. I think I know what's going to happen. 10 squared minus 4 times 5 times 5, and that's going to be 0. It's 100 minus 100. And when you have a discriminant of 0, you have 1 real solution, because you're taking the square root of 0, and that does give you a real number. And finally, for number 4, the discriminant is b squared minus 4 times a, which is 3, times c, which is 2. That's 100 minus 24, which is 76. And when the discriminant is positive, you have 2 real solutions because it's plus or minus. We're going to look at something like this where these are already factored. and we're going to see if we can find the roots. When you find the roots of something that's already factored, you change the sign. Okay, if this is x minus 3, the root is positive 3, and this is x plus 2, the root is negative 2. I put set brackets around those, and I am done. In order to solve by factoring in part B, I'm going to get it equal to 0 by adding 20 to both sides. Let's rewrite it as x squared minus 12x plus 20, and that's equal to 0. And I'm going to factor it like this, and then we're going to see if we can find the roots from there. If it's x squared, is going to be x times x. What are the factors of 20 that add up to 12? I think it's 10 times 2. 10 times 2 is 20, and 10 plus 2 is 12. The c value has a positive, so that means the signs are the same. My middle term is minus, and so that means it's going to be minus minus. And so my final solutions are going to be positive 10 and positive 2 because it's opposite signs. Okay? Next question with square roots. Find the solutions with square roots. I'm just going to do normal equation solving methods. The first thing I'm going to do is add 64 to both sides, and so that gives me x squared equals 64. I'm then going to take the square root. To eliminate a square root, you take to eliminate a squared, you take the square root of both sides. And remember, the square root of 64 is 8. And when you take the square root, you have to include a plus or a minus because there's two solutions. So plus or minus 8. Last question here. Last question on the entire exam, because if I look on the back, there's nothing there. So this is going to wrap it up. We're going to use the quadratic formula. I'm going to write the quadratic formula here, and we're going to plug all of our numbers in. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Again, you're going to have a formula sheet with these formulas on it, so you don't have to memorize it. I do think your Algebra 2 teachers make you memorize it, so if you can get it in your brain now, that would be good. I'm going to write this as x squared plus 2x minus 3 equals 0 to get it equal to 0. I'm going to make myself a little list. The a value is 1, the b value is 2, and the c value is negative 3. I'm going to take these numbers, we're going to plug them into the quadratic formula. X equals negative b is negative 2, plus or minus the square root of 2 squared minus 4 times a times c, and that's all divided by 2 times a. Okay, let's simplify this a little bit here. Negative 2 plus or minus the square root. What do we have under here? We have a negative 4 and a negative 3, so I'm going to change the negative negative to a plus plus. Underneath the square root is 2 squared, that's 4. 4 times 1 times 3 is 12, and 4 plus 12 is 16, and that's all divided by 2. Now we know the square root of 16, and the square root of 16 is 4, and that's all divided by 2. So my solutions are as follows. Negative 2 plus 4, which is 2, divided by 2, and that's 1. And negative 2 minus 4, that's a negative 6, and negative 6 divided by 2 is a negative 3. Those are my roots to the polynomial using the quadratic formula. Well, I hope this has been helpful for you. Again, if you have any questions, you can let me know, ask a neighbor, text me on Remind, and I'll try to get back with you as soon as possible. The algebra exams are going to be first hour tomorrow morning on Tuesday at 7:25. And fourth hour exam is going to be Wednesday at 9:10 a.m. after your third hour exam. And your sixth hour exam is going to be Thursday at 9:10 a.m. as well. Hope you guys have a wonderful day, and we'll see you this week. And we have 3 more days to go until summer. Bye-bye.